Geothermal studies include a broad range of investigations aimed at understanding and utilizing geothermal resources for energy production. Here are some key aspects and areas of focuses with geothermal studies. Resource assessment. Geothermal resource assessment involves evaluating the potential of a specific location or region for geothermal energy production. This includes estimating the geothermal resource's temperature, volume, and permeability, which are essential factors in determining its commercial possibility. Geological surveys. Geological surveys play a fundamental role in geothermal studies. They involve mapping the geological features on an area, such as the distribution of rocks, faults, fractures, and volcanic activity. Understanding the geological characteristics help identifying potential geothermal basins and determine suitable drilling locations. Geochemical analysis. Geochemical analysis involves sampling and analyzing fluids, gases, and rocks from the subsurface to determine their chemical composition. This helps in identifying the presence of geothermal fluids and estimating their temperature, salinity, and composition. Geochemical data is essential for understanding the nature of geothermal basin and its potential for energy extraction. Geophysical exploration. Geophysical methods are widely used in geothermal studies to image the subsurface and identify geothermal basins. Techniques such as seismic surveys, gravity measurements, magnetic surveys, and electrical resistivity surveys help identify subsurface structures, fluid pathways, and heat sources that are indicative of geothermal resources. Well drilling and logging. Well drilling is a crucial step in geothermal studies. It involves drilling deep into the subsurface to access the geothermal basin. During drilling, various measurements and logging techniques are employed to characterize the rock formations, assess temperature gradients, determine fluid characteristics, and evaluate the basin perspective. Reservoir engineering focuses on understanding the behavior and performance of geothermal reservoirs. It involves analyzing the flow of geothermal fluids, estimating reservoir properties such as permeability and porosity, and optimizing the energy extraction process. Reservoir engineering also includes modeling and simulation to predict reservoir behavior and optimize the design of geothermal power plants. Environmental and social consideration. Geothermal studies also involve environmental and social assessments. These assessments evaluate the potential impact of geothermal development on the surrounding environment, including water resources, ecosystems, and local communities. Economic possibility studies are conducted to assess the possibility and productivity of geothermal projects. These studies consider factors such as resource potential, drilling cost, power generation technology, and market conditions. Economic analysis help determine the financial possibility of geothermal projects and informs decision-making processes. Geothermal studies involve an interdisciplinary approach combining geological, geophysical, geochemical, engineering, and economic analysis to evaluate geothermal resources for sustainability energy production.